Today, we are opening a set of source documents that reveal one of the biggest and I think most painful disconnects in modern business. We're going right past the typical 60 or 7% failure rate for big organizational changes.
Which is already high.
Which is already terrible.
Yeah.
And we're diving into a world where failure is, well, it's almost guaranteed.
It's a jaw-dropping figure. I mean, our sources are estimating that up to 95% of AI initiatives fail to deliver their intended value.
95%.
You'd expect some setbacks. It's a new technological frontier, but that level of failure it's systemic.
And what makes that 95% number so terrifying is just the sheer volume of capital being deployed here.
Oh, absolutely.
This isn't small pilot projects anymore. Global enterprise spending on AI systems is projected to exceed $300 billion annually by 2026.
$300 billion.
That's a monumental investment that is, right now, mostly just evaporating.
And that's really our mission in this deep dive. We need to isolate the disease here, because if that much money is yielding almost no results, the core problem is not in the code.
Right. The tech itself is good.
The systems today are remarkably capable. The systematic failure lies in what happens when these sophisticated systems collide with the very complex architecture of human behavior.
So we're looking past the technical specs.
Completely.
We're focusing entirely on the people side of change, what the sources are calling the behavioral, human-centered AI framework.
It's the idea that no matter how good the model is, its success or failure is really determined by the human beings who have to actually use it.
When you're hitting a 95% failure rate, you have to accept that you're not fighting bad software engineering.
No. You're fighting fundamental, evolved psychological patterns. That's the real barrier.
Okay, so let's unpack that gap. Beyond 95% failure, the numbers also show that only about 26% of companies report any tangible, measurable ROI from their AI. Why is there this colossal misalignment?
It really boils down to a fundamental belief system that we call technosolutionism.
Technosolutionism.
Yeah, it's this mindset, and it's pervasive in leadership, that the technological sophistication alone, the power of the model or the complexity of the pipeline, will just automatically overcome these deep, messy organizational problems.
It's the belief that if you just build the perfect digital tool, all the human problems will sort of sort themselves out. It's framing AI adoption as a purely engineering exercise.
You can actually measure that belief system in how leaders assign responsibility.
Oh, so?
Well, we saw one survey of chief information officers, CIOs, and it found 71% felt directly responsible for accelerating AI innovation.
Okay, high technical engagement. That makes sense.
But contrast that with this. Only 32% felt responsible for the organizational transformation. The behavioral shifts, the retraining, the process overhaul needed for that system to actually work.
Wow. So that split is everything. Massive engagement on the build side and almost no engagement on the change management side.
That is the 95% failure rate staring you right in the face. You've deployed a brilliant tool into an organization that has not been prepared at all to use it.
And that lack of preparation, that's what triggers the resistance.
Precisely. And we have to understand this resistance, it isn't just irrational obstruction from employees. It stems from these fundamental, evolved psychological patterns. We've identified 3 critical cognitive barriers that just consistently derail these projects.
Okay, let's get into the first one.
The first one is loss aversion. Behavioral economics tells us that humans feel losses about twice as strongly as they feel equivalent gains.
Right.
So when employees are confronted with a new AI system, where does their mental energy go? It's not on the potential 10% productivity boost.
No, they fixate on the perceived losses.
Exactly. The loss of control, the loss of their comfortable workflow, or the big one, the looming specter of their skills becoming obsolete.
So that potential threat is weighted far more heavily than any promised reward.
It's profoundly powerful. The carrot really needs to be twice as big as the stick. But too often, leaders are presenting this tiny little carrot while holding a massive stick.
So if fear of loss is the initial friction, what's the next human wiring issue we hit once the system is actually deployed?
That would be algorithm aversion. Humans are, and this is fundamental, just unwilling to tolerate errors from a machine that they would easily forgive in a human colleague.
So even if the algorithm on average, is outperforming a human 9 times out of 10.
It doesn't matter. We see that people have this deep-seated tendency to just abandon an algorithm after seeing even one minor error.
Especially if they're the one who catches it.
Especially then. One visible screw-up is enough for the user to pull the plug, to trust their gut, and just go back to the old way of doing things. They hold the machine to an impossible standard of perfection that they never, ever apply to the flawed human processes they've always used.
And I imagine that reluctance gets reinforced by our third barrier, the availability heuristic.
That's the one. This is that mental shortcut where our brains just overweight vivid, memorable examples when we're trying to evaluate how reliable something is.
So the big dramatic AI failures, even if they're statistical outliers, they stick in our memory.
And they fuel this widespread skepticism. This is why those stories become legends. When Amazon had to scrap its AI recruiting tool because it was biased against women.
Right, I remember that.
That wasn't just an internal failure. That single vivid headline fueled this generalized distrust in all algorithmic hiring systems across dozens of industries.
Exactly.
And the consequence of letting these barriers run wild is severe. Organizations develop this internal learned helplessness dynamic.
It's like organizational trauma.
It is. A failed implementation doesn't just cost money. It depletes political capital, it destroys trust, and it makes the entire organization risk-averse about adopting anything new in the future.
So it locks them out of competitive advantage for years to come.
It can take years to rebuild that institutional confidence. So if the problem is behavioral, if it's psychological, then the solutions have to be designed for human cognitive architecture, not just for, computational throughput.
We had to design systems that earn trust, not demand it. Where do we even begin?
We begin with transparency. The number one solution for building appropriate reliance is something called explainability.
Okay.
Providing transparent, easily digestible explanations for why an AI made a recommendation. It significantly increases user trust and, this is the crucial part, it encourages appropriate reliance.
Because it meets that deep human need for understanding and for feeling like you have some control. If I know the reasoning, I feel like I'm still part of the evaluation.
Exactly. I'm not just blindly following an oracle. And this leads to some pretty counterintuitive design tactics. For instance, sometimes we need to introduce what's called selective friction.
Friction. Wait, that sounds like the absolute opposite of efficiency. Why would we intentionally slow a user down?
Because faster isn't always better if that speed leads to complacency. There was this fascinating piece of research on AI transcription tools. They found that using slightly harder to read fonts actually improved human error detection.
Get out. Really?
Yeah. That minor obstacle, that bit of friction, it forced users to slow down, to increase their scrutiny, and to engage analytically with the output instead of just scrolling and rubber stamping.
So the goal isn't just speed, it's maximizing accurate human-machine collaboration. That's fascinating. Can we see this kind of redesign in a really high-stakes scenario?
Oh, absolutely. Look at IBM's Watson for oncology.
Okay.
Early on, the resistance from oncologists was profound. The system gave these complex treatment recommendations, but it was essentially a black box. Doctors were being asked to trust an opaque machine with a patient's life.
I could see why they'd push back.
But physician acceptance improved substantially, not when the tech got better, but only when the user interface was redesigned.
And what specifically changed?
They redesigned it to show the supporting evidence. It showed the relevant literature citations and the system's own confidence levels for every single recommendation.
So the technical output was the same, but they addressed the doctor's psychological need for validation and control.
And the system went from being rejected shelfware to a trusted, augmenting tool.
So design can help fix the trust issue. But what about that initial loss aversion, that feeling that a tool is being forced on you?
We address that by leveraging the endowment effect.
Right, the idea that people value what they help create.
That's it. This requires inclusive co-design. You have to involve the employees, the actual end users, in the design process right from the start. It builds psychological ownership.
It sounds great, but it also sounds like it could really slow down a project, and leaders always want rapid deployment.
It can add time up front, but it pays back exponentially by guaranteeing adoption and avoiding catastrophic flaws. This is key. Diverse co-design fixes critical issues that a purely technical team would just miss.
Do you have an example of that?
A major study of automated speech recognition systems revealed that all 5 of the big systems made about twice as many errors for Black speakers.
Wow.
And that's because of a lack of diversity in the training data. It's a massive functional flaw that diverse user input would have caught immediately.
So co-design isn't just about getting buy-in. It's about actually fixing the product.
It is. Look at P&G. They involved their brand managers heavily when they were developing AI tools for consumer insights. And this collaboration reveals something totally counterintuitive to the tech team.
Oh, is that?
The managers valued the speed of insight generation far more than analytical comprehensiveness. They just wanted actionable data fast.
So the tool was redesigned for that specific human value.
And the adoption rate soared to 89%, far exceeding their historical average of 40%.
That leads directly to the importance of framing, doesn't it?
Right.
The difference between talking about automation versus augmentation.
Framing is everything. Automation triggers that loss aversion, my job is being replaced. Augmentation triggers opportunity, my capacity is being freed up.
So you have to explicitly show what the AI is taking off someone's plate and what new higher value work they get to do instead.
Exactly. Deloitte mastered this with their audit processes. They used AI to handle the really tedious tasks, transaction sampling, anomaly flagging, the stuff nobody enjoyed.
But they didn't just automate it.
No, they explicitly reallocated that auditor time toward client advisory work and complex judgment calls. That concrete capacity release created genuine professional opportunity.
And the result?
An 85% auditor adoption rate. It just proves that redesigning the job description around augmentation works.
Okay, so we've designed for trust and ownership. Now, how do we scale that success and keep the momentum going? This feels like it gets to the value of gradual rollout and quick wins.
You have to start small. Target achievable improvements. Demonstrate value immediately. A huge, high-risk rollout just amplifies the damage if you stumble, and it confirms everyone's pre-existing algorithm aversion.
Small, visible wins create internal champions.
And they build the political capital you need for a wider adoption.
The classic example here is Walmart's AI for inventory management.
Right. They avoided that massive, risky rollout. Instead, they started with a limited set of high-visibility products in just a few select stores.
And what did they show?
They quickly demonstrated a tangible 30% reduction in out-of-stock situations.
That's a win that's undeniable, it's measurable, and it's repeatable.
And that generated momentum store by store, allowing them to scale successfully.
Sustained success also seemed to require transparency about the inevitable failures. That feels like a paradox.
It is the paradox of trust. Honestly, communicating the system's constraints, its known error patterns, and its boundaries, that actually increases user trust and tolerance for mistakes.
It sets a realistic expectation, makes it feel less like a deceptive black box.
Capital One did this really well with their AI fraud detection. They didn't just launch the algorithms. They gave detailed communication to their reps about how the system worked, its known limitations, and, this is critical, the specific human review processes for flagged transactions.
So by communicating the oversight, they reinforced that a human was still in the loop.
Exactly. And that transparency led to high employee adoption and high customer acceptance.
So finally, we have to look long term. We have to address that risk of automation complacency, the tendency to over-rely on these systems without monitoring them. How do we keep the system alive and learning?
You have to establish continuous learning systems. Sustaining AI's value requires mechanisms that actively gather that real-world user feedback to refine the model's performance over time.
Like the JP Morgan Chase coin tool for contract intelligence. That's the gold standard here, isn't it?
It really is. They set up these dedicated feedback channels where their lawyers could flag any issues with the AI's contract interpretations. A cross-functional team reviewed that feedback every single week and communicated the changes back to the lawyers.
So it's a constant dialogue.
It's a dialogue. The tool got smarter, and the users felt heard, which kept them engaged.
So if you're a leader pouring resources into AI today, what does this all mean? I mean, it seems like the ultimate competitive advantage isn't going to be found in the technical specs of your algorithm.
Not at all. It's the investment in behavioral expertise, in organizational psychology, and in real change management. Success requires leaders to confront their own biases, their technological optimism, their overconfidence.
The complexity is at the human interface, not in the computational engine.
That's where the path to escaping the 95% failure rate is. It's paved with empathy and behavioral design.
And the final hurdle seems to be maintaining that balance, that dynamic between appropriate trust and necessary vigilance.
It's the total tightrope walk. So let me leave you with this final provocative thought. The journey requires these continuous learning systems that actively prevent automation complacency. So how do organizations balance encouraging all this amazing AI usage, getting those immense productivity gains, while simultaneously maintaining the healthy human skepticism that's necessary to catch system drift, detect new errors, and prevent the trauma of another massive failure?
That is the real challenge ahead.